Okay, so this is the today's Codeforces contest. First problem was like given an array, you need to return a permutation, not a permutation. You need to return a basically given a number of elements in the array, just n. You have to return the array such that it satisfies the condition that your array should have a length of this much, like n, and the sum should be divisible by n, and yeah, every number must be also divided by n. So what thing which you can do is simply I think you can print something like 2468 kind of thing, right? Yeah, like that satisfies the thing, right? You can start off with let's say one, and you say like n I plus plus. You are just gonna say c out into two, c out, and that's what you have to do for the test cases. And let's say if you have this like that, then yeah, it should be fine. T and just print 2n for that, right? So this 2 obviously it satisfies the condition that it's divisible by 1. The sum is divisible by 1 also. 2 4, the sum equal to 6 divided by 2. And similarly for 3, the sum is equal to 6 plus 4 plus 2, which comes out to be 12, again divisible by 3. And yeah, the thing is that, and every number is obviously divisible by that because it's just y. So yeah, at the index, yeah. So that was about the first problem. Contest is over. So what? Submit. Okay. I think we currently system testing is going on or something like that. So okay, let's see. Yeah. Let's move to problem B. Given t number of test cases, number n, and then what you have to do. Given array also, it's a permutation. Okay, so an element should be 1 to n. You have to sort this permutation using this thing, like using some swapping. So you'll swap. The swap is not just like you can swap any two elements. The condition for swap is that you can swap two elements if the index difference between these two elements is equal to k. I minus j is equal to k, then you can swap these two elements, and then you have to return the maximum value of k that you can choose to solve the given permutation. Okay, this might look like maximum value. So what should you do? Should you do binary search? Should you do DP kind of thing? But yeah, the answer lies in just the problem tag. That's math question, neither binary search nor the DP. I initially tried binary search, thought of that, like for example, if this is the k which is optimal, which is the maximum k that you can have to solve the permutation. The thing is that it's not like binary search. You need what you need in binary search. You need like something for like there is a big breakthrough point. You need a breakthrough point in a binary search. For example, the answer on this side is yes, so yes, 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 and there is a breakthrough point, and then the answer is no, no, no. So this breakthrough point is my answer for the binary search. So you can say this is the maximum point where yes occurs, okay, or the minimum point where no occurs, something like that you can say. But yeah, it's the thing is that for this question, you for example, you can see by looking to the test case that if the k is the maximum answer, it doesn't mean that, right? It doesn't mean like if k is the answer and the answer for k is yes, it might be the case that there is no, and there is again yes, and there is again no. It can be the thing. So the answer is not like, it's not like changing in a linear fashion. It's not like changing like this fashion, like from one point to another, like from yes to no or no to yes. It's not like that, okay. Or for example, if like 4 satisfies the condition, like 4 satisfies the thing that okay, 4 is the maximum, is the value of k that can solve the permutation. It doesn't mean that 5 will also sort, or it doesn't mean that 3 will also sort, right? So this is the thing. Now what you can do, let's move to the logical problem. So the thing is that the thing which you have to just focus, if the you can swap the elements having distance k but also having distance 2k, because you can swap it two times. Also distance 3k, you can swap it three times. So what you can have is that, let's say, it would be very clear if I can take us some kind of an example. and just you are basically, if this k is the answer, you, which means, let's say k is equal to, let's take a value k equal to 4, right? K equal to 4, which means that you can have 3 and then you can swap it with something which have index like 4 after 3. So 1 2 3 4, I think 9 is 4 after 3, and something which is 4 after 9 is 1, right? And that's all about it. And then if you start with 10, then you have 9, like 1 2 3 1 2 3 4. Okay, so you will have 6, and then one you'll have 4. So these are the things which you have. Okay, you don't have, like, you also have 5, and 5 will go up to, let's say, we'll say 6 or 7, 9 7, and then nothing else, because you already reached 4. There is nothing after this 4, right? Similarly, you can start off at 2 and then can go plus, like, let's say index for this 2 is 0 1 2 3. 3 plus 4 is 7. Seventh index is something like 7, like 8. It would be something like that, right? So this is the thing that you can sort. Okay, these are the 3 9 1 are the indexes which you can sort, and this 10 6 4 are the indexes which you can not sort, you can just reorder in any way which you want, so that you have them this. So the answer lies in this only. So you have n, you have, again, like, if I can say, okay, you need an array also, kind of thing. Yeah, you need an array of size n. Let's say it starts from 0, n, c, n, a of I. So this is your permutation. Now what you can do is that, like, for finding that value of k, you're gonna say that, um let's see, like, again, the sorted permutation looks like this. This is nothing to tell about this. This is the sorted permutation 1 0 5 6 7 8 9. Now, for the sorted permutation, to make it like this, you see which index are, like, no, which index are good, which index are not good. Like in this case, there has to be one at the first place, but there's three at the first place, so three is not good. Okay, what else you can have? Now 10. Okay, so 3 is not a good place. 3 needs to go to something like at an index 3. Where it needs to go? It needs to go at this 5. So I want to swap 3 with 5, right? This is what I need. This is what I need, right? The 5, I want to swap it with something like this. What is placed at the index 5? At index 5, you see 9 is placed. So I need to swap 3. So I need to swap 3 with 5, and 5 with 9. Then further, if you say, like, what do I need to swap this? Okay, what's happening? Yeah, 5 with a 9, and like, how, like, 5 goes to this place, and 9 goes to something like 7 8 9 10, I think. Yeah. So for 9, I want to have something like this place. Which place is this? Basically, whatever place is this, but I want to have this, right? 3, and then this. Yeah, yeah. So what I want is basically, if you see, like, just like this, 3, I want to swap it with 5. So the distance I want is 2 or 1. If I say 1, it would be wrong. Yeah, yeah. I need to have a distance of 2. So for 3, k is equal to 2. If k is equal to 2, you can swap 3 with 5. So I'm saying 3 requires k equal to 2, so that you can swap this 3 with 5. So this 3 comes over here, and this 5 comes over here, and yeah, that's fine. Now again, like, this is what you need to do for rest of the thing. So for 10, you need something which can take you there, right? Okay, what's the, yeah, whatever the length would be, like, you want to make it reach at the ninth index. Currently it's at the first index, so the difference is something like 8. 1 2 3 4 5 6 7 8. So yeah, k equal to 8 is what you want. Okay, fine. Then you'd say, like, obviously, if k equal to 2 you are keeping, you can have k equal to 8, because any gcd of this, any multiple of that would be possible, because that's what I said, that like, you can swap 391, because, like, it's 2k, and it's 3k, right? Because you can have a step of k. So that's how you have to proceed, and just find the distance which you have to travel, which you need to swap it to make it at the good place. at its original position where it should be. So how I'll be doing that? I'll be doing that like this, and I equal to 0, I is less than n, I plus plus. I'll be saying that okay, your x is equal to, let's say, fi minus where it needs to be. A of I is where it needs to be, and where it's currently is at I, right? Okay, this is the thing. So for example, 3 3 4 5 was there, something like that, and there was 1 2 3, and 3 needs to go over here, right? Currently 3 is at the first place, so we need k equal to 2. So 3 minus 1, which is equal to 2. A is 3, I is 0, so I'll do I plus 1. Okay, so that is it. And then you have to take GCD of all, so that you fit in, like basically, whatever is the greatest common divisor that you have to take, so that you satisfy all. If GCD comes out to be 1, then yeah, that's your answer, 1. Like, all this operation is always possible because sorting is always possible, right? Now, what can I do with this is that, I can have it all in the vector term, something like r dot push back, and then we'll find how we'll do that. R dot push back x, and then what I need is just for auto I in r, g is equal to underscore gcd of g comma I, where g is something like, let's say, r0, c of g, and l. One thing which you need to make is r vector include bits std plus plus dot h, and then you have this. Yes. Hmm. 1 2 3 4 3 2 3. Okay, so what's happening over here? Yeah, you have to take absolute, obviously. Okay, so that is the thing. uh, Let me show you my summation instead. This is the thing where I have done this vector. Okay, so the name is a over here. X goes to, like, this thing goes to, okay, only if it is something like not 0. Yeah, if it is 0, then yeah, there would be a problem. Like, taking GCD with 0 would be a problem, right? So fortunately, in this case, there is no one like that. You can say, but yeah, that's about it. So yeah, only if X exists, then you push it, and then you have GCD over here, right? So let's move to C. Or should we try D first? Okay, let's try D first. Given the problem, you've given a permutation, not a permutation, just a given array. You are required to sort, not just required to sort the array. You need to return some integer answer. That integer answer would be this: calculate the sum beauty of, or all the subarrays of the array. So go on each subarray, calculate the beauty, and then sum them all. So for that, you need to go on all subarray. If you need to go on subarray, you n square, you can have n square, but this problem is not just n square problem. This is the, the only difference between these two problems is hard problem has a constraint of n up to 2 10 is per 5, which means it is possible to do this quotient in, let's say, n log n. You don't need even to go or all the subarrays. So just try to think about that, how you can avoid going all the subarrays. The thing which I have like figured out till yet now is that, let's take example for this. You want to sort it completely, right? No, 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 you don't want to sort it. You want the answer for each subarray kind of thing. So subarray of length 1 will give you answer 0. So that's 0 into n. But yeah, that's about it. Now subarray of length 2, how many subarrays, or NC2 subarrays of length 2 you can combine. and not in C2, just n minus 1. Yeah. So 2, 6 is fine. Okay, it's fine. It's giving you, let's say, answer equal to 0. And then you have 1630 given 0, 13 3 given 1, and 315 given 0. And then you have 15 5 given 1, then 510 given 0, then 1, then again 0, then like 0 for this, then again 1 for that, and then again 0 for this, and yeah, 0 for that. So this is the 9, 10, 18. So that's what I did. First sub array is 2, 6, 0 for that. Then 6, 13, 0 for that. 13, 3, 1 for that. 3, 15, 0 for that. 15, 1, 1 for that. And then 5, 10, 0. 10, 8, 1. 8, 16, fine. 16, 9 is not fine. And then all are fine. So the thing which you got from the length 2 is 1, 1, 1, 1, 4. So that's your answer from the length 2. So length 2 contribution is this. And then let's say you have, obviously length 2 will give 1 only if it need. So out of, like, let's say 11 pairs, only 4 of them would need sorting kind of thing. Length 3 would be more interesting. So 2, 6, 13, fine. 6, 3, 13. Like, now what is the array which you pick up to sort so that it becomes good? So 3 you need to have at least at the first index. Okay, so for that you have to pick this up. You have to pick this up. So length 4 we are talking about. This gives 0 first, 2, 16, 15, fine, and then this is not fine, so this gives, let's say, 3, or yeah, 3. It gives 3. You need to have this 3 completely sorted, and then this can be sorted in just one operation. Yeah, this is the thing. They're saying r minus l, not length, r minus l, so it would be 2 and 1. And then you have this fine. Then 3, 15, 5, that goes with this again 1. And then 15, 5, and 10 goes with, let's say, 1. No, it doesn't go with 1. You need to have 15 at the last. So 3. So how I'm calculating the answer now, it's really good to see that how I'm calculating the answer. So I'm saying that I will see a particular subarray which need to be sorted. So if some part of it is already sorted, let's say, I know what is the minimum in this, I know what is the maximum in this. I know, like, 5 should be the minimum, and 10 should be at the like 15 should be at the last. So you see that, okay, to what point do I need to sort? Okay, so neither 5 is at the first place, neither 15 is at the last place. So just straight away say that you need at least 3 operation. Yeah, that's about it. But let's pick up a big subarray. Let's say this. What is the maximum? What is the minimum? Maximum is 16, minimum is 1. So you need to have 1 in the first and 16 in the last. So neither of you have that, right? But still, can we do something good about it? If you look carefully, this 315 is sorted, 5 is sorted, 816 is sorted. Even this, anything else? Nah. So it's like continuous valley and peaks. So basically, like, how to approach this kind of thing? Like, I only thought of like this: where there is a starting point and there is an ending point, and obviously, if this is a sub-array that you want to make good, to have it as sorted, does it always really need that you'll always do r minus l? No, it always doesn't need. Let's say first things are at the good place, some last things are at the good place, or some middle things even are at the good place. You don't need to do operations for that. You just need to do operations for those continuous elements that are not at a good place. R. Let's say if it would have been like this, and some 1 to 3 is fine, right? Then 4, 5, 6 may 5, 4 becomes 5, 4. 6, 7 is fine. Then let's say 9, 8 it becomes, and then it becomes 10, 11. Okay, This part is sorted, right? 1 to 3 part is sorted. 5, 4, 6, 7 part is sorted. You don't need to do operations for that. You don't need to do operations for that. You need to do operations for this, so you need 2. And then 6, 7 is fine even at this place. And then you need to do operation 2, 1. Sorry. Yeah, 1, 1. So that's why the answer for this length 11 is also 1. But how would you find out that? Yeah, need some hints. Hmm.